at this point, it's time to actually test it in a real application, a real AI application. Now, you could use ChatGPT. The problem with ChatGPT is you have to be on a wait list to be able to actually load your own custom plugin, right? And John somehow managed to get access. I don't have access, and I'm sure many of you don't have access. So what we get to do is, I don't know, twiddle our thumbs? No. What we have done in the Semantic Kernel team is actually create a test bed for you to test your plugins. And we call that Chat Copilot. So I'm going to go ahead and pull up our Chat Copilot application, and we are going to go ahead and get it started. Yarn start. If I can type in a command correctly, yarn start, there we go. So basically what I've done is I've checked out the Copilot chat app, which is inside of the Semantic Kernel repo. We actually believe it's matured enough that it deserves its own repo. So hopefully by the end of the week, you'll be able to find it in its own repo. And it comes with two main parts. It has a web API, which is the back end, and we have the front end. I've gone ahead and configured it beforehand. But once you do have it configured, you can easily run the back end and the front end, which you saw me do. And it's actually loaded. So we can actually start using this thing. If you're using OpenAI, which I am right now, do not forget the period. Do not forget the period between 3 and 5. Azure, for whatever reason, they don't have the period. So make sure you add it. And then the other super important thing to pay attention is this planner setting at the bottom. We'll talk about what planners are in a bit, but it starts off with action. Again, we'll describe what these things are in a sec, but you want to make sure you change it to sequential, okay? Okay, great. So we have our Chat Copilot. Oh, it's so nice and clean. It's empty. And what we want to do is test our brand new plugin. So we're going to hit this plugin button. There's this nice little card to add your own custom plugin. We're going to go ahead and add localhost 7071, add our plugin. We have it down here. As I mentioned, we forgot a logo, so it's currently broken, but whatever, it's fine. It's fine. We're going to go ahead and enable it. And now we get to test it. So this is the moment where every single demo person goes, oh shoot, I'm demoing a non-deterministic AI piece of software. It's going to potentially blow up on me. So if everyone in the crowd, if everyone can please cross their fingers for Matthew. And we're going to ask, please summarize, if I can spell, please summarize the Wikipedia article about Microsoft. Okay, we'll hit enter, and it's thinking. Now, creating a plan can take a bit, so we're just going to wait a bit, but very soon we should see, and we didn't have to wait very long. We now have a plan being returned back from the Chat Copilot, telling us how it's going to combine these steps, step 1 and step 2, get wiki text, summarize text, so that it can actually satisfy our request. Super cool stuff, right? And I can do this, I can test this without having to pay OpenAI, which we love. We love OpenAI at Microsoft. Without having to pay OpenAI $20 a month. I can do this for free, locally on my machine, minus the few API calls I'm making. So I'm going to go ahead and say, yes, proceed. The bot is typing, it's thinking. And within a little bit, it's going to finish completing this plan and hopefully tell us all about Microsoft. Alrighty. So it tells us Microsoft Corporation is an American blah, 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 blah. It works. It freaking works. And just to kind of reinforce the value of plugins, let me actually restart all this. If we ran our Chat Copilot without enabling a plugin, so we can look, it's not enabled, and we ask, please summarize the Wikipedia article from Microsoft. If we did that, the LLM models that come with OpenAI, that come with Azure OpenAI, they don't have access to Wikipedia, and they've been trained to politely say, I can't do it. Say, look, I'm sorry, but I don't have access to the internet or articles about Wikipedia. And you get something similar from ChatGPT. And so the power of giving plugins is you can give additional superpowers to your bots, to ChatGPT, to your own bots that aren't possible with using the LLMs alone. This is super cool stuff. I hope you appreciated this demo of creating a plugin. You haven't seen the last of it yet. I'll be back. But John's going to tell you a little bit more about how this magic is actually working. So as Matthew teased, I'm going to now explain how these copilots, how things like ChatGPT actually work. Because, I don't know, maybe it's obvious to all of you, but for me, it wasn't clear how these AIs actually knew how to use a plugin until I really started to understand what is happening under the covers. So drum roll, please. What is this thing? What is actually making it possible? It's planners. The magic, the AI that combines plugins together to accomplish a user's goal. Now, planners are really the heart of what Microsoft calls the Copilot chat stack. At the bottom, you obviously have the foundational models, the AI infrastructure, all the great stuff that OpenAI and Azure OpenAI provide all of you to use. Now, up top, we've already been talking about plugins and copilots and all the great experiences that you can build. But that layer in between, how do you actually tell your application which plugin should be used next, and how do they actually come together, right? And you do that with a planner. Now, for us in the Semantic Kernel team, to make it easier for app developers like yourselves to understand what's actually happening, what we've done is actually open sourced. We've shared our code. It's up there of how our planners actually work. And we have 3. They show the evolution of what we experience as we've developed planners in our research labs. And those are an action planner, sequential planner, and stepwise planner. Now, we'll describe what each one of them does and how they differ, but at a high level, what you see on the right is a planner takes a bunch of building blocks, a bunch of plugins, a bunch of functions, combines it with the user's goal, and figures out how to rearrange them, combine them to create a plan. And you might remember from Matthew's demo in the chat Copilot, the Copilot actually showed a plan to the user before it acted on it. So what are these different planners that we at Microsoft provide? So as I mentioned, they kind of show an evolution of what we at Microsoft have kind of experienced. The first thing we ever developed is what we call today an action planner. And many of you probably have already started doing this with LLMs. It's, hey, given a user's goal, an intent, what is the one next thing that we should do to achieve that goal? And this is kind of the default experience in Chat Copilot. That's why Matthew recommended you to change that setting. And if you have it on, all it will ever do is give you back a plan with one step. Which is great for very simple scenarios or if your plugin has very high level actions. But most of the time, you actually want to combine multiple actions. And so what we at Microsoft discovered is you could actually tell an LLM to come up with a multi-step plan. And so the next thing that we came up with was called the sequential planner. And that's what you actually saw Chat Copilot use. With sequential planner, you basically ask the LLM to create an entire plan, all the steps in one go, with how the results go from one function to another. Once you have this plan, it's really helpful, as you saw in the Chat Copilot, because you can actually show the entire plan before it runs. You can ask the user if it's okay. And then when you hit run, the semantic kernel is smart enough to take these plans, these steps, run them, and return back the results. What's new, when I say new, like a couple weeks ago, is what we call Stepwise Planner. And this is kind of state-of-the-art what a lot of other open source projects use, what ChatGPT probably uses. And what it does is, instead of trying to solve everything in one go, we're only picking a single action, is it iterates. It tries to accomplish a plan and reevaluate and ask itself, am I done? And not until it says yes will it give up, or if you tell it to give up. And so to show you kind of the power of something like Stepwise Planner, I'm actually going to pass it back to Matthew, and he's going to show you how something like Stepwise Planner works today. So to give you a taste of how the Stepwise Planner works, I'm actually going to take a break from the wiki plugin that we were building, and instead go to the math plugin that I showed earlier that's part of the documentation. So if you do follow that documentation, you'll have a plugin that has functions like adding, dividing, multiplying, subtracting, a bunch of math things that LLMs are actually pretty bad at. So this is a good example of using plugins to augment the power of an LLM. Now, all of this is already kind of built and done and ready for me to go ahead and press the play button. As an FYI, I did switch back to VS Code. It's my happy place. But trust me, you can use the same sample inside of Visual Studio if you want. So I'll go ahead and click play. It's going to enable my plugin locally. Here we can see all those endpoints, those math endpoints that we saw earlier. And then we can bring it into our Stepwise Planner. So here I have a very simple program file. I've created a logger so that we can actually see what's going on. This is really helpful when you're building an enterprise application with something like Semantic Kernel. You want to be able to see all of this non-deterministic behavior so that you can start adding guardrails in the future. And then we'll go ahead and create a kernel similar that as before. We're loading in those settings and getting it built. And now we're actually going to load in that plugin. Now, previously, I showed you how to load a plugin using the Copilot application. But if you want to do it directly from code, it's super simple. All you have to do is tell it where this plugin is, and we've provided a helper function called import ChatGPT plugin, and it takes in that manifest and pulls in all of those APIs. So we can use it, in this case, with the Stepwise Planner. Here, I'm creating that new Stepwise Planner. Creating the other planners like action and sequential are very similar. You pass in a question, you ask it to create a plan, and then you invoke it. You start it. You say go, right? And it'll think, it'll do things, and give us back a result. So I could click on this play button, and I could show you what's going on. But I find with planners, in particular, it's helpful to look at the source code to see what is actually going on behind the scenes. So I'm going to go ahead and go to Semantic Kernel. So if I've already checked it out, go to the GitHub, look at all the different samples that we have. Again, we have .NET and Python flavors. I want to go ahead and go into the .NET version and then drill into where we have our different planners. And each planner, as John mentioned, is powered by an LLM. So that means it too has prompts. So we already showed you how to create a prompt with our plugin, right? But these planners are no different. They too have a config, and they too have a prompt. They have some additional kind of logic to orchestrate all these plans, but at the heart of it is a prompt. Okay, and we can take a look at the prompt of the Stepwise Planner to start seeing how it works. So it has some instructions. Follow the questions as accurately as possible. Okay, cool. Available functions. So we paste in all the functions that were imported using that helper function I showed earlier. And then there's some instructions that we give to the AI, some usage instructions, some examples. And then we can start seeing the thought process. So with this thought process, we're teaching the LLM, the AI, how to complete a goal step by step, how to be wise with their steps. It's taught always start with a question, describe your thoughts, take some notes, basically, perform an action, observe the action, and then once they're done, once they've actually come to a final answer, then they can print a final answer that we can give to the user. Okay. So that's kind of how this prompt works, right? And this extra code that you can check out if you really want, all it really does is help extract and put in the values for some of these pieces. Okay. It extracts the action and actually performs those results. So now that we understand how this prompt works at a fairly high level, let's actually watch it in action. Again, this is where having something like a logger is super helpful, because we can start seeing how these LLMs think. And if you have a real service, you can log this stuff, so if something does go wrong, you can always go back in time and see what went wrong. Okay. So I'm going to go ahead and click play. And let's just let it run. Let's see what happens. Let's give it a little bit more space. And let's go to the debug console. So it's debugging, it's thinking. And as part of Semantic Kernel, what we do is we always log the rendered prompt and what came back from the LLM. And so as this run, we'll actually see this get long. I guess it just needed 2 actions to accomplish our question, which is a simple math problem. Hey, I have X amount of dollars, and it grew by X number, and how much would I have left if I then spent some money at Starbucks? And we can see the prompt that we just saw earlier, right? So all the standard kind of boilerplate at the top, we list those available functions. So here we're seeing all of the math operations, those instructions, and we can even start to see the thought process of the LLM, right? So begin. The LLM is like, okay, this is the question from the user. It has the thought to solve this. I need to use the functions multiply and subtract. Wow, that's pretty cool. It's actually using those functions to solve a problem. It then creates a JSON action blob so that the semantic kernel can actually perform one of these actions. And it gets an observation back. Hey, the result of multiplying is 2200 and some odd amount. So it then has the next thought, the next step. Okay, great. So now that I know what the result of the multiplication is, I can now subtract the cost of the latte. So here we're seeing the action of subtraction, right? It gets the observation. And at this point, the LLM is smart enough to know that this is the answer that solves the initial question. And so we can finally print out final answer and what the actual result is. And this result is what's ultimately sent back to the user. So if we look at our code, we can see at the very end, we print the results. If you have 21, 30, and some odd cents, and it grows by this amount, you would have this amount remaining. And what's great about this is if you just asked an LLM without these math operations, it would hallucinate and come up with some random weird math operation. But because we gave it a plugin, because it was smart enough to use these functions as part of the Stepwise planner, it was actually able to give us the right answer. Pretty neat stuff. And so with that, I'm going to go ahead and pass it back to John. Now, as cool as planners are, they aren't perfect. There's a few challenges with them. One, they're only as good as their plugins. So we've kind of mentioned already that the descriptions of plugins are incredibly important. If you get a bad description, your plugin is not going to be used well, and the planner is going to do things you probably don't want. The other challenge is while we, the Semantic Kernel team, have open sourced our planners, you can see the actual prompt that is used so that you can best create descriptions for your planners. Most other services don't do that. ChatGPT, it's a black box, right? To both users and devs. And so a ton of testing is required to make sure that your plugins work. And then lastly, you run into issues like token limits, right? The prompt that we just saw for the Stepwise planner is not short. And if you're just using GTP 3.5, it's easy to run out of space within your prompt and ultimately not get a successful plan back. And so the solution that we've found that addresses most, if not all, of these problems is to take your functions that you've already created and start to create higher order functions. So instead of having a bunch of atomic functions like, hey, get a Wikipedia article, get an answer, get annotations, do summarizations, et cetera, et cetera, et cetera, what we recommend is finding those key scenarios that your customers routinely use and create higher order functions. Create a single function, in this case, something like get answer, that calls multiple steps in order together in a single block. And what this does is it simplifies the job of the planner. Instead of having dozens of functions, maybe it has just a handful. And because you just have a handful, you're having to do less optimization for each of the different planners across the ecosystem. And because you're not giving it so much work for it to do, you will less likely hit token limits.